Have you ever wondered how we can restore images or signals to their original state after they've been distorted? Today, we'll explore the fascinating world of deconvolution. In mathematics and engineering, convolution is a fundamental operation that combines two functions to produce a third function. Deconvolution is the reverse process, aiming to recover one of these original functions. Deconvolution plays a crucial role in signal processing and image restoration. It helps us correct the blurring effects that often occur due to physical limitations or distortions. In convolutional neural networks, CNNs, deconvolution operations are used for tasks like image segmentation and upscaling. However, it's important to note that this is not exactly the inverse of traditional convolution. Fourier deconvolution, a computational method, reverses the effects of convolution by transforming signals into frequency domain and applying mathematical corrections. This process can restore original images or sounds. The practical applications are vast, from enhancing medical imaging to improving the quality of photographs. Affected by motion blur and camera shake, deconvolution helps recover details lost during acquisition. In summary, deconvolution is a powerful tool in signal processing and image restoration with wide-ranging applications. Its ability to reverse the effects of convolution opens doors for clearer images and signals. Today you learned about deconvolution and its importance in restoring original signals and images. How do you think this technology could impact future advancements?